This is the EdExcel GCSE 9-1 Maths Foundation Paper 3 from the sample papers, and this paper is a calculator paper. Question number 1, we have to write 2148 correct to the nearest 100. Well, if we've got a number line, and if we write our number correct to the nearest 100, that means our number will be in between 2100 and 2200. Our halfway point is 2150, and our number is less than the 2150, and therefore we would round down to the 2100. Question number 2, we have to simplify for part A, 8x subtract 3x plus 2x. Well, 8 subtract 3 is 5, plus another 2, that's 7. So we end up with 7x. Then for part B, we have to simplify 4y times 2y. 4 times by 2 is 8. Y times y is y squared. Question number 3. There are 6,760 people at a rugby match. 3,879 of the people are men. 1,241 of the people are women. 1/4 of the children are girls. We have to work out how many boys are at the rugby match. Well, if I add together the 3,879 to the 1,241, it turns out we get 5,120. So there are 5,120 adults at this rugby match. We can now find out the number of children. We've got 6,760 people altogether. Subtract the number of adults, 5,120, and it turns out there's 1,640 children. And we know that 1/4 of the children are girls, so if we work out 1/4 of 1,640, we get 410 girls, and therefore the number of boys will be 1,640. That's how many children there are. Take away the number of girls, 410, and it turns out there will be 1,230 boys. Question number 4. Here is a grid showing the points A, B and C, and for part A we have to write down the coordinates of the point A. Well, for the point A, we go 3 across, 5 up, so the coordinates of A will be 3, 5. For part B, on the grid we have to mark with a cross the point 1, 2 and label this point D. So 1, 2 is over here. We will label this with point D. And for part C, on the grid we have to mark with a cross a point E so that the quadrilateral ABCE is a kite. Well, we could have, for example, point E being over here. The consequence of is if I join this point with this point and this point with this point, we can now see we've got a kite. Question number 5. Pfizer buys 1 magazine costing £2.30, 1 paper costing 92p, and 2 identical chocolate bars. Pfizer pays with a £5 note and she gets 40p change. We have to work out the cost of 1 chocolate bar. So if she pays with a £5 note and gets 40p change, what we can see from here then is the total cost of everything will be £5, take away 40p, and this is equal to £4.60. So everything altogether costs £4.60. Now, if we let x equal the cost of a chocolate bar, well, we've got our magazine costing £2.30, our paper costing 92p, plus 2 identical chocolate bars, so that's 2 times by x. The total of all this is £4.60. So we've got £2.30 plus 92p, that's £3.22 plus 2x equals £4.60. And if I do £4.60, subtract this, I get £1.38. So that means 2 times by x is equal to £1.38. And if I divide this by 2 to find out the cost of one chocolate bar, it turns out x is equal to 69p. So we get 69 pence. Question number 6. The bar chart gives information about the number of students in the 4 Year 11 classes at Thornton School. We've got the grey bars representing boys and the black bars representing girls. For part A, what fraction of the students in class 11A are girls? Well, we've got 14 plus 15 students altogether. So we've got 14 plus 15, which is 29. So in class 11A, we've got 29 students. And so of these 29, how many of them are girls? Well, that will be 14 of them. Rather, girls, that will be 15 of them. Then Shola says there are more boys than girls in year 11 in Thornton School. Is Shola correct? You must give a reason for your answer. Well, what we'll do is we'll first of all find out the number of boys and then the number of girls. So for the number of boys, we've got 14 plus 12 plus 8 plus 4. So there's 38 boys. And for girls, well, we've got 15 plus 11 plus 7 plus 5, which is also 38. What we see is there are an equal number of boys and girls, and therefore she is incorrect. Now, the pie chart gives information about the 76 students in the same 4 Year 11 classes at Thornton School. Tolu says it is more difficult to find out the number of students in each class from the pie chart than from the bar chart. Is Tolu correct? You must give a reason for your answer. Well, I think she's correct, and that's because you need to measure each angle and then convert it to the number of students. So that's why it's more difficult. Question number 7. Here is a number machine. We input, we times by 3, we subtract 4, we get an output. For part A, we have to work out the output when the input is 4. So we start off with this 4. After this, we would have to multiply this 4 by 3. After this, we subtract 4, and then we get our output. So we start off with the 4, we times it by 3. We then subtract 4, we get the output being 8. So the output is 8. Then we have to work out the input when the output is 11. Well, for this we need to use inverse operations. So we start off this time with the output being 11. From this, we need to work out the inverse of subtracting 4, which is adding 4. Then, after this, instead of timesing by 3, we would have to divide by 3. And then after that, we get the input. So, we start off with the 11, we add 4 to it, then we divide the result by 3, we get an input of 5. So we have 5 for the input. Now, what we have to do for the next part is show that there is a value for the input and the output have the same value. Well, what we need to do is let the input and the output equal x. So what we're saying over here is we start off with the x, and then we times by 3, and then we subtract 4, and then we get our output, which is x. So if I times x by 3, I would get 3x. And then I subtract 4 from this, and the result of this is x. So, first thing I'll do is subtract x from both sides. So that means 2x minus 4 is equal to 0. Then I will add 4 to both sides, which means 2x is 4, which means x is 2. So we have the same input and output when x is 2. Question number 8. 1 yard is 36 inches and 10 centimeters is an approximation for 4 inches. We have to work out an approximation for the number of centimeters in 2 yards. Well, first of all, in 1 yard, we will have 36 inches. And therefore, what we have for 2 yards will be 72 inches. Now, the way we got this was we multiplied both sides by 2. So, at this point, we need to convert this into centimeters. What we know is 10 centimeters would represent 4 inches. And what we need to do is find out the number of inches for the number of centimeters for 72 inches. Now from here to here we times by 18. And therefore if I times this by 18, we would get 180 centimeters. Question number 9, we have to work out 234% of 150. Well, 234% is the same as 2.34 as my decimal multiplier. And then I need to times this by 150. So we've got 2.34 times 150, and we get 351. So we have 351. Question number 10. Here are four numbers: 0.43, 3/7, 43.8% and 7/16. We have to write these numbers in order of size. Start with the smallest first. Well, what we can do is write each of these as decimals. So I've got the 0.43, we'll leave that alone, but then 3/7, that's equal to 0.428 571 4286. 43.8% is 0.438, and 7/16 is the same as 0.4375. So when we order them, the smallest one is this, followed by this, followed by this, followed by this. So if we were to write those down in the original format, well, this value corresponded to the 3/7. After that, it was the 0.43. After that, it was this value, which corresponded to the 7/16. And after that, we had this value, which corresponded to 43.8%. Question number 11. Here is a list of 5 numbers. From the list, we have to write down, for the first part, a prime number. Well, a prime number is a number which has 1 in itself as factors only. That will be 17. Then we have to write down a square number. Well, 16 is an example of a square number because 4 squared is 16. Question number 12. Here is a star shape. The star shape is made from a regular hexagon and 6 congruent equilateral triangles, which means that they are the same. The area of the star shape is 96 centimeters squared. We have to work out the area of the hexagon. Well, what we can do is split this shape up further into triangles. Now, I'll demonstrate this in red. What we can see here is, for a regular hexagon, we have, well, a regular hexagon has 6 triangles. And what we see with the star shape is we've got 6, 7, 8, 9, 10, 11, 12. So the star shape has 12 triangles. So we've got 96 centimeters squared, which is represented by 12 triangles. So what we need to do is find out what area is represented by 6 triangles. Well, that will be half of 96, which is 48. So we have 48 centimeters squared for the area of the regular hexagon. Question number 13. WXYZ is a quadrilateral. XYV is a straight line. For part A, for the first part, we have to find the angle marked A. Well, for this, we'll notice we've got a straight line, and angles on a straight line add up to 180. So we've got A plus 147 equals 180. which means A is equal to 33. And the reason that we did this calculation, angles on a straight line sum to 180. And now what we have to do is, well, we're given that the angle ZWX is equal to the angle WXY, and we have to work out the angle ZWX. So if we say that this angle here is equal to X, adding this to the diagram, we have X here and X over here. And then we've got this angle here, which is equal to 33. So what we can recognize is, because the angles in a quadrilateral sum to 360, we would have X plus 145 plus the 33. This is all equal to 360. And the reason for that, angles in a quadrilateral sum to 360. So we've got 2x plus 178 equals 360. So we've got 2x, which is equal to 182. So x is equal to 91. Question number 14. The total weight of 3 tins of beans and 4 jars of jam is 2080 grams. The total weight of 5 tins of beans is 2000 grams. We have to work out the weight of 1 tin of beans and the weight of 1 jar of jam. Well, what we know is 5 tins of beans is equal to 2000 grams, which means T is equal to 400 grams. And then we are told that 3 times by the weight of the tin of beans plus 4 jams is equal to 2080. So I've got 3 times by 400 plus 4 times by the jams equals 2080. So I've got 1200 plus 4 jars equals 2080. And if I subtract 1200 from both sides, 4 jars of jams will equal 880, which means 1 jar is equal to 220. And we've got the beans is 400. Question number 15. There are 25 boys and 32 girls in a club. 2/5 of the boys and 1/2 of the girls walk to the club. The club leader picks at random a child from the children who walks to the club. We have to work out the probability that this child is a boy. Well, we've got 2/5 of 25. This is equal to 10. So we've got 10 boys who walk, and then we've got 1/2 of 32, which is 16. So we've got 16 girls who walk. And what we can see from here then is 10 plus 16, that is 26. So we've got 26 children who walk. And therefore the probability that the child is a boy, well, we've got 10 out of 26, which is equal to 5 out of 13. So out of 13, 5 of these, well, 5/13 is the probability that the child is a boy. Question number 16, we have to change 72 kilometers per hour into meters per second. Well, we've got kilometers and we've got meters. Well, here, if I times by 1,000, and then here, if I divide by 1,000, we can convert between kilometers and meters. And then we've got hours and seconds. Hours to seconds, we times by 3,600. Seconds to hours, we would have to divide by 3,600. So if you've got 72 kilometers per hour, we can convert this into meters per hour. And the way we do this is we multiply the 72 by 1,000, which is 72,000 meters per hour. And then what we need to do is divide this amount by 3,600. So if I do that, I would have 72,000. Then I need to divide this by 3,600. And this will convert it into meters per second. So I end up with 20 meters per second. For question number 17, here is a rectangle made of card. It's got dimensions 2x and y in centimeters. Lily fits 4 of these rectangles together to make a frame. The perimeter of the inside of the frame is p centimeters. We have to show that p equals 8x minus 4y. Well, the length from here to here is 2x, which means as well the length from here to here is also 2x. Now if I've got 2x here and I know already that this length here is y, and I also know that this length here is y, and also this length here is 2x. That would mean then that this length here will be 2x, subtract y, subtract another y, so this length here is 2x, subtract 2y. and therefore this here is also 2x minus 2y. And therefore, for the perimeter P, we have 2 multiplied by the 2x plus 2 times by 2x minus 2y. So, we have 4x plus 4x minus 4y, which is equal to 8x minus 4y. That's what we wanted to show. Next, Magda says, when x and y are whole numbers, p is always a multiple of 4. Is Magda correct? You must give a reason for your answer. Well, so far, we know that p is equal to 8x minus 4y. And if I factorize out a 4, that means I would have 2x minus y inside the bracket. And because x and y are whole numbers, then 2x minus y is also a whole number. Question number 18. The diagram shows a trapezium ABCD and 2 identical semicircles, and we know that the center of each semicircle is on DC. We have to work out the area of the shaded region. Well, we've got DC, which is 12 centimeters, AB, which is 28 centimeters, and the height of this trapezium is 14 centimeters. Now, first of all, we can recognize that 2 semicircles make a full circle, which means if I halve DC, I will get the diameter of one of these semicircles, which is 6 centimeters. And so therefore, the radius of the semicircle will be half of the 6, which is 3 centimeters. We can now find out the area of the circle. We would have pi multiplied by 3 squared, which is 9 pi. We can also find the area of the trapezium. The area of the trapezium, we've got 1/2 times by the sum of the 2 parallel sides, 12 plus 28, multiplied by the height of 14, so it turns out we get 280 centimeters squared. And therefore, the shaded area is equal to 280 subtract 9 pi, and if we work this out, we get 251.72, etc. centimeters squared. So we've got 252 centimeters squared given to 3 significant figures. Question number 19. Asif is going on holiday to Turkey. The exchange rate is £1 equals 3.5601 lira. Asif changes £550 to lira. We have to work out how many lira he should get. Give your answer to the nearest lira. Well, we've got £1, which is equal to 3.5601 lira. What we want to do is change £550 into lira, which means I have to multiply the 3.5601 by 550. And it turns out in this case we would get 1,950 58.055 lira. So to the nearest lira, we've got 1,958. For the next part, Asif sees a pair of shoes in Turkey. The shoe costs 210 lira. Asif does not have a calculator. He uses £2 equals 7 lira to work out the approximate cost of the shoes in pounds. And we have to use £2 equals 7 lira to show that the approximate cost of the shoes is £60. So we've got this conversion rate, £2 equals 7 lira, and what we know already is 210 lira is the cost of shoes. So this 210 would correspond to the cost of shoes. So what we do here is we multiply by 30, which means I have to multiply this side by 30, which means I will end up with £60. So we've shown that the approximate cost of the shoes is £60. Now for part C, is using £2 equals 7 lira instead of £1 equals 3.5601 lira a sensible start to Asif's method to work out the cost of shoes in pounds? You must give a reason for your answer. Well, what we know is £2 equals 7 lira, and so therefore £1 is equal to 3.5 lira, just halving it. So we've got a good approximation, and that's because 3.5 lira is close to the 3.5601 lira. Question number 20. Here are the first 6 terms of a Fibonacci sequence. The rule to continue a Fibonacci sequence is the next term is the sequence is the sum of the 2 previous terms. We have to find the 9th term. Well, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, 8 plus 13 is 21, 13 plus 21 is 34. We've got here 34 being the 9th term. Next, the first 3 terms of a different Fibonacci sequence are A, B, A plus B. We have to show that the 6th term is 3A plus 5B. So we've got A, then we've got B, then we've got A plus B. So the next term will be B plus A plus B, so that will be A plus 2B, A plus B plus A plus 2B, well that will be 2A plus 3B, A plus 2B plus 2A plus 3B is 3A plus 5B. So we've got the 6th term being 3A plus 5B. And then for the next part, given that the 3rd term is 7 and the 6th term is 29, we have to find the value of A and find the value of B. So we know that the 3rd term, which is A plus B, this is equal to 7, and we also know that the 6th term, which we were told is 3A plus 5B, this is equal to 29. We have simultaneous equations which we need to solve. If I call this equation 1 and this equation 2, what we can do is get the b's the same by multiplying equation 1 by 5. And if I do that, I would have 5A plus 5B equals 35. We'll call this equation 3. And now, if I do equation 3, subtract equation 2, 5A subtract 3A is 2A, 5b minus 5b is 0b, 35 minus 29 is 6, 2a is 6, a is equal to 3. And then, knowing that a is equal to 3, we've got 3 plus b equals 7, b is equal to 4. So we have a is 3, b is 4. Question number 21. In a survey, the outside temperature and the number of units of electricity used for heating were recorded for 10 homes. The scattered diagram shows this information. We've got the outside temperature in degrees C and the number of units used. Molly says, on average, the number of units of electricity used for heating decreases by 4 units for each degree C increase in outside temperature. Is Molly right? Show how you get your answer. Well, what we could do, for example, is draw a line of best fit. And if I draw a line of best fit, I could have something like this. This is the line of best fit. And then what we can do is find out the gradient of this line. Now I've got this point here, which is 0, 85. And I've got this point here, which is 30, 12. So what I need to do is find out the gradient. And I can do that using the change in y over the change in x. So for the gradient, I've got the change in y, 85 take away 12, of the change in x, 0 take away 30. So if I work out what the gradient is in this case, 85 take away 12 over 0 take away 30, we get minus 2.43. And so she's wrong because it decreases by 2.43 units for each degree increase in outside temperature. Then for part B, you should not use the line of best fit to predict the number of units of electricity used for heating when the outside temperature is 30. Give one reason why. Well, 30 is over here, and what we can see from our data is, well, here is all our data, and 30 is outside that data. So 30 is outside the data set. It's outside of the data over here somewhere. Question 22. Henry is thinking of having a water meter. These are the two ways he can pay for his water that he uses. With a water meter, we've got a charge of £28.20 per year, plus 91.22p for every cubic meter of water used, and 1 cubic meter is 1,000 litres. With normal water meter, we've got a charge of £107 per year. Henry uses an average of 180 litres of water each day. We have to use this information to determine whether or not Henry should have a water meter. Well, I've got this 180 litres per day, and if I multiply that by 365, because it's 365 days in a year, then what I end up with is 65,700 litres per year. And if I divide this by 1,000, I would end up with 65.7 meters cubed per year. So for the cost, we would have the fixed charge of £28.20, and then we add on 65.7 multiplied by the cost per cubic meter, which is 91.22p. So let's find out the cost. We've got 28.20 plus 65.7 times 0.9122. So we get a cost of £88 and 13 pence. So clearly this is less than the £107 per year from the fixed charge, and therefore we can conclude the water meter is cheaper. Question 23. A and B are two companies. The table shows information about the sales of each company and the number of workers for each company in 2004 and 2014. So for part A, we have to work out the percentage increase in sales from 2004 to 2014 for company A. So we're looking at sales for company A from 2004 to 2014. So the percentage increase is equal to 388 take away 320 divided by 320, and then I will multiply this by 100. So if I work out what this is, we get 21.25%. So we've got 21.25%. Next, which company had the most sales per worker in 2014, company A or company B? You must show how you get your answer. So what we are looking at over here is, in 2014, the sales per worker. So let's take a look at company A. Well, we would have to do 388 divided by 3,200, and if I work out what this is, we would get 0.12125 million per worker. And if we take a look at company B, well, we would have to do 57 million divided by 640, so here we've got 57 divided by 640, and if I work out what this is, what we end up with is 0.0890625 per worker. And because this amount is smaller than this amount, company A had more sales per worker in 2014.